stick on to the basic things. Just know what we concluded, no? Stick on to that basic things. Okay, I'll proceed like this. So this block, no, I'll just show a dot like this, huh? So that we can draw the diagrams. So initially, this is at rest. There's a spring is relaxed. I'll call point P. So now, so the moment I'll start moving it, so here the spring will get elongated and the velocity of descent is fixed here. So the spring will get elongated, spring force kx1, kx1. Because of this acting here, the block will have, say, velocity v1. Why it will have velocity? Because spring force acting, because of force acting, it will accelerate. Because of acceleration, it will acquire speed when it undergoes some displacement. And this np, I maintain it constant velocity v0. It is moved with a constant velocity v0. Then further next situation, v0, this is p. So the spring will further get elongated. So let the velocity be v2. So definitely I can say v2 greater than v1, x2 greater than x1. What will happen to velocity of this left end of the block? Will keep on increase, no? Will keep on increase. At one instant, both the ends of the spring now, block as well as the end p, will have common velocity. And that common velocity, I'll take it v0. And here is, I'll call now the elongation is maximum. Now you have to ask me questions, sir, how you can justify it. Look at the spring force is acting towards side. Further acting on the block, what it will do? It will accelerate the block. It will accelerate the block. And because of that, the velocity of the block now will become greater than the velocity of the free end. So here, call V3, this is V0. So here V3 will be greater than V0. Can you say this maximum elongation? No. So if you check it again, x2 less than xm, x3 less than xm. So where maximum elongation? Maximum elongation is possible here. Again, what is the basic necessity condition? At maximum elongation, what will happen to the ends of the spring? They must have common velocity. That's what the idea I'm bringing it here. I'll write it here only. Maximum elongation. Next, after this, what will happen? Because the velocity of the block is more than that, further, what is the next situation? Compression will occur. Compression. So next, if I go for further, there will be velocity as the velocity of the block is more than that of the NP. So next, this elongation start decreases, no? Elongation start decreases. So here, from elongation now, shall I say, it will attain natural length. Then what is the state of the block? At rest or in motion? Here it will have velocity. So this is the, what is the, and look at the V. What do you expect the V? Greater than, what do you expect the velocity here? Is it greater than V3 or less than V3? V should be greater than V3 and there's a natural length. Suddenly from maximum elongation cannot attain natural length. Maximum elongation then natural length. After this, what is the sequence? Now the velocity of the block is more than that. So you can see that one V is greater than V3 and V is greater than V0 also. So now what will happen to the block? Spring will undergo compression. Here the spring force will act like this. So what is the state of spring? Compression. Okay, clear this. So what is the velocity of this? call V4 something. Now what do you expect V4? V4 will be less than V. So it is undergoing now compression. Again at maximum compression. Like that, the sequence will get repeated here also. Maximum elongation. XM means maximum elongation. XM, the symbol itself, maximum elongation, I wrote it, no? Maximum elongation in the spring. Okay, what is our question now? So Veda is asking to calculate the maximum elongation and maximum mechanical energy of system. Okay, how to bring this? Okay, this sequence, what happens? Okay, we are able to put it. So shall we put here elongation increases from here to here, elongation increases, then elongation decreases, natural length, then compression starts increasing. How to bring that energy, mechanical energy of the system here? Okay, let's go back to the initial. What are the relative velocity between the block and the point P? Initial relative speed between them. What is the relative speed? V naught. And again at natural length, what is the relative speed? The relative speed should be equal, no? Because the sequence is same, no? So what is the state of spring here? Natural length. Now also here natural length. So the natural length, I'll look at that blue color one. So what is the relative speed? The relative speed of the spring must be, so what is the relative speed? V naught. So U relative is equal to V minus V naught, and that should be equal to V naught only. Comparing what? Comparing state of spring at natural length. So what is V equal to? 2V naught. Okay, look at here. There's no elongation in the spring. So block is having mass. So what about the mechanical energy? This should be M 2V naught square by 2. So this should be 2M V naught square by 2. This is what? Maximum mechanical energy of the system. Not at maximum elongation, it will not have maximum mechanical energy. The mechanical energy will be maximum again when spring attains natural length. After this, how to get the maximum elongation one? So now let's do one thing. Come for that one. What is work done by spring force? How the block will acquire velocity V naught, the spring force only. Just look at only this one. What is the state of the block? Rest. Now what is the state of the block? In motion. Now from how the block has acquired kinetic energy, the spring force doing work only. So therefore, work done by spring force, work done by spring force should be equal to change in kinetic energy of the block. Change in kinetic energy of block. What is work done by spring force? Kx dx 0 to xm should be equal to mv naught square by 2. Solving this, we'll get